So, we are all set. Let's learn about HTTP. Let's give our rather nervous speaker a big round of applause and make him feel comfortable. Have a good time. You're going to do great.
Okay, so we should add some demo, but maybe it won't work. No demo. Mic, like this. Okay. So it's Sunday morning. I hope you are all well enough. So this will be about HTTP. So why Wookiees? Wookiees because this is about smuggling, and Wookiees are smugglers. And also because the Wookiee language is a thing, quite hard to understand and easy to misinterpret. So this was the nice thing for HTTP also. So what are we going to talk about? Something about the HTTP that you need to know. What is HTTP injection? Some recent attack vectors. HTTP 0.9, which is on old versions. Maybe not the demo, you'll get to trust me. And maybe we'll talk about the tool I wrote, which is called HTTP Wookie. So who am I? Regilero, because it's French. Yes, it's not Wookie, but maybe sometimes you won't understand my words. I work on a very small French free software web company, which is called Makina Corpus, 50 people. I'm a DevOp. I've always been a DevOp, so it means I'm a sysadmin and I'm a developer. Web security is just a very small part of my job, and it's part of my spare time also. And this is important because if I can do it on my spare time, some other people might be doing it better than me. So why did I start testing my tools? I work every day with open source HTTP servers, and I like these tools a lot. And I used to trust these tools a lot. But I found two very interesting papers. The first one is HTTP hosted real-world attacks. And this is about very old stuff in HTTP, which is the absolute theory in location. There's some tricks with this, so you can attack the host header on HTTP. And there are real threats with this sort of attacks, 2015, for example. The other one is a study from 10 years ago, 11 years ago, which is HTTP smuggling, and everything is inside. Most of the things I can tell you today are already inside, but it's like everyone forgot it. So, what is HTTP smuggling? It's a protocol level attack. So it's injection, and everything always is injection. Here, we are gonna inject HTTP in HTTP. So we're gonna have more requests or more responses than we should. And to do this, we'll craft low-level HTTP messages. By definition, you cannot do this with a browser or an HTTP library because they do not make mistakes. So the goal is to make mistakes. When you make mistakes, usually you get errors, but not always. So before we start, the first things on HTTP is the very old version of HTTP was one TCP/IP connection for each resource. Like you want a file, you want an image, you want a CSS file, you need one new TCP/IP connection for each resource. Then you do the SYN ACK thing, you make your request, you get your response, and then you try to close the TCP/IP connection, and there are problems when you try to close because we're not sure you get the answer. This is a big performance killer, of course, because you may need a lot of TCP/IP connections. So they made Keep Alive on HTTP 1.1, That is, you reuse the same connection, and when you get your response, you can make another request. You'll get a new response, and you make another request. And you can, in fact, usually your browser will use 6 TCP IP connection and do this, unless you're using HTTP2, it's what you are. There's also something that most people doesn't know, there's pipelines. So instead of waiting for each response before doing the next query, you can send every query and wait for every responses. On the example, you can see that I made 4 queries and I get 3 responses only, which is allowed. But the important thing is the order of the responses. So if one of the responses is huge, you get to wait for this response before adding the next one. So this is called head-of-line blocking, and this is also a performance problem. And this is one of the reasons of HTTP2. And the other reason of HTTP2 is smuggling, because you depend only on the order of the messages. And in HTTP2, you've got a real binary multiplexing thing where each response can be associated with a request, and it's better. If you get a reverse proxy, like an SSL terminator or a reverse proxy cache, if you make a pipeline to the reverse proxy will talk to the backend without the pipeline. It will make just a simple HTTP 1.0 or 1.1 keep alive connection, but it will not use a pipeline when it talks to the backend. The problem is the backend doesn't know that there's no pipeline. So if you can make the reverse proxy play something which looks like a pipeline, the backend may see several requests and send several responses, but the reverse proxy doesn't want several responses. This is smuggling. You've got one example here where I send something which should be only one query, but the final step has a splitting issue, so now you've got 2 queries and you've got 1 extra response, and the problem is on the question mark. What do you do when you've got 1 extra response? And you've got 2 types of things, which are the transmitter, which transmit the bad syntax, and you've got the splitter, which splits on this bad syntax. And the 2 are problems, but the splitter is the real problem. So why do you do HTTP smuggling? Maybe just because you want to hide a query. So maybe the reverse proxy would like to prevent this sort of query to happen, but it doesn't see the query. You can make crash. You can crash a lot of things when bad syntax are used. You can try to shift the response stream, like if you insert 1 extra response on a pipeline, you may really shift the stream and do cache poisoning. And you may also try to hijack another user credentials on HTTP by using incomplete queries. And this is the thing on the demonstration. All these things were described in 2005 already. So we also need exploits. Oh. It's not me. It's the Mac. It's my day. Thanks a lot. So the exploits, it's all about size, because we are in a pipeline, we've got several messages in a pipeline, and each one has its own size. So the goal is to alter the size. You can make double content length headers, so people doesn't know which one is the right one, and this is strictly forbidden. You can play with content length and chunked transmission, and you should not play with both. On chunked transmission, you do not have a length for your message. You say, I will send things, and when you see the end of chunk marker, it's the end of the message. You could use invalid errors or invalid values, like the content length with a space is not a valid error. You could use also invalid end of lines, like the first one, the real end of line is CR LF. You could try to use LF also, it's almost valid, but CR is not valid as an end of line. You could also try to use very old features of HTTP, which are still there, like HTTP 0.9, like multi-line headers, which are in the RFC. So the first demo, at least you can read the thing. Here, this should make an hijacking credential exploit. So here you've got some real-world exploitation. Like this was working on Node before the version 5.6. It's a splitting issue. You should always have CRLF for end of line. But for Node, if you add the CR, they thought that they do not need to read the next character because it's always LF. But if it's not, you've got a problem. So on the example, you've got the dummy header, and then you've got the CR on a Z character, which is not an LF, and any other thing. So for everybody, this is just one header, which is dummy header, CR, Z, transfer encoding chunked. It means nothing. But for Node, there are two headers. The first one is dummy header, which means nothing, and then there's a transfer encoding header. So for everybody, this request is one request, and in blue, you've got the body of the request. And you can make a GET request with a body. It's allowed. So this is just one request with a binary body that nobody reads. But for Node, you've got transfer encoding chunked, and there's a priority, and chunked always has the priority on content length. So it does not read content length. It reads chunked, and the first bytes of the body is the end of chunk marker. So after the end of chunk marker, you've got a new request in a pipeline. You've got a post request. And this post request is, please delete user 2. There's another thing on this second request. There's a partial header at the end. So it's an unterminated post request. Node is still waiting for the end of this request. So what could happen if you got a reverse proxy in front of Node with a keep-alive connection with Node, and the first proxy gets the first response, like he's thinking, this is one query, I need one response, so he gets one response. Then Node is just waiting for a second query, and another user, like the admin user, is there, sends a query, any query, and the query gets appended to the unterminated one. With the new user credentials, like the cookie, like an HTTP authentication credential, and then the admin user is doing a post user delete 2 without requesting it. So I cannot show you because there are problems with the screens, but at least I can show you what happens. I'm the attacker. I send a request to Varnish, which is a reverse proxy cache. And this request is the request you just saw. Like you've got, in fact, 2 requests, but it's just one. And the request goes to Node. Node has a splitting issue. So he knows things. There are 2 requests, and he sends back 1 response. Then another user came for a new request, which is request C. Varnish reuse a keep-alive connection with the backend, so send the request C, which is appended to the unterminated request, and then you get response B, which was my hidden request. And the user 2 is deleted, only if you do not have CSRF protection on the post request. So this is a way to run this attack. It's just a request. I run it on Linux with a printf and netcat, just to put the content in a TCP IP connection. And I do it 150 times just to feed every Varnish TCP IP connection in the pool of backend connection with the node, and it works. Believe me, you can try. You've got everything on the CD if you want to try. It worked before it was fixed on node. There was a second demo. And this one is about HTTP 0.9. So HTTP 0.9 is something awful which should not exist. It was the very, very first version of HTTP where you do not have any headers. So you've got an example of what is HTTP 0.9, 1.0, and 1.1. On 0.9, you do not have the protocol version. You just the method and the location, and no headers. No headers, it means also no headers on the response. But the security of HTTP is in the headers, like the content type, the cookies, the content security policies, the content length, everything is on the headers. On HTTP 0.9, you've got just the body of the answer. So it's just a text stream. If you've got a text stream, maybe you can make this text stream look like a real HTTP response with headers. So for example, you could make an image, and the content of the image, instead of being a binary thing, would be an HTTP response with headers. And if you request this image in 0.9 mode, it may look like an HTTP response. You could also try to hide this part, this HTTP message in the EXIF data of the image, and make a range query to get only this part of the image. So you get a real image, and if you request the right part of the image, you've got an HTTP response. But you should not be able to do a range request in HTTP 0.9 mode. So another problem is the no cache poisoning. Like maybe you know about cache poisoning in HTTP, but for cache poisoning, you need a cache. No cache poisoning is in fact socket poisoning. Like take TCP IP sockets, and you hide response on the sockets. And another user, when the socket is reused, get the response. So this is a real thing on Apache, for example. So this was the thing we could try. Like here, we've got a splitting issue on Go, where Go is fixing your syntax, like transfer encoding with a space is fixed as transfer dash encoding. So for everyone, the line transfer encoding chunked means nothing, but for Go, it's a real line. So same as before, the blue part is now a new request. There's the no cache poisoning, we'll use it. There's another bug on Go, which is that we can ask for HTTP 0.9 which does not exist. And this makes a 0.9 query. It should not work this way. And there's a third bug on Go where we can make a round query in 0.9 mode. It should not exist because in 0.9 mode, we should not read the request headers. So you make a request with a splitting issue on the golang reverse proxy, for example. Here I've got an Apache reverse proxy, which transmits the request to Go. I've got a splitting issue on Go, so Go is doing this request against Nginx. It targets an image and takes only the HTTP part of this image, which gets back in HTTP 1.1 mode, but for Go it's an HTTP 0.9 request, so it removes the headers of the response and sends you back the real thing. It's hard to understand without the demonstration, but it works. It means I can request with the Go an HTTP response which is hidden in an image on a server. Inject this response on the streams of response. But there's another problem. For Apache, if we get back, there was only one request, and it gets one response. Then there's a new response which comes back, which was the response hidden in the image. And for Apache, there's nothing to do with this response, so nothing's happened, and the response is stored on the TCP IP connection. Then, when a new request is coming for Apache from anybody, Apache reuses the same TCP IP connection with the backend, send a new request, and read on the TCP IP connection to see maybe I have a response inside, and he see that he has a response and takes it and send it back to the user. Just before getting the real response, which was, hey, no, you should not reuse this connection. This is an RST on TCP IP because there was a 0.9 response, so you should not reuse the connection. But it's too late. The message was stored and was sent back to the user. So you can store a response in Apache and get this response with maybe an XSS or maybe everything you want, like any header you want, any content security policy header, and send it back to every user. So this is the way to do it if you want. You need to run a lot of requests because you need to feed every TCP IP connection. And I cannot show it to you, but it works. What can I say about it? The real problem on these things are the splitting issues. If we get back just a little, here, this is the real problem on Go, and it's fixed now. As soon as you have a splitting issue, bad things happen, like having an extra response sent back. And for Apache, the fact that you've got the no cache poisoning is a public issue. It's not a security issue, because they consider that there was a security issue for Go, there was a splitting issue, and what happens after that is not their problem. It's a little their problem, but it's complex to manage. If you think that the backend is doing bad things, you cannot do anything. So for every splitting issue, you should get a CVE, because for me it's quite critical. But usually project leaders do not like doing CVE on these things, and maybe sometimes they do not understand how you can exploit the injection. And because also they do not want people to try to do things with these issues. The other issues are transmission of that strange syntax. Like, yeah, I had something which is quite very strange syntax, like transfer encoding with a space. You should not have any header with a space in the header title. And a reverse proxy could detect that this header is invalid and could reject your query. But usually they do not do this. So there's a big problem of responsibility because everyone is trusting every other one, and no one wants to take the full responsibility of the problems on things which looks like smaller things. For security researcher, a warning, you will not earn money with HTTP smuggling because you cannot test it like an XSS thing. You cannot take a public infrastructure and try to break everything because you won't be the only one impacted on this. You may crash everything. You may send back response to people that have nothing to do with you. So it's very hard to test on public servers. I earned one bounties with a golang issue from Google, but it was unexpected, and it's very hard to usually explain to people that maybe they should upgrade their servers. The other thing is that we should have more people reading the code of HTTP servers. Like there are a lot of issues which are still there, and we need people which really do not trust blindly the code. Things get better. Years after years, the issue gets fixed, and you should really try to upgrade to avoid problems. Some other exploits, maybe because we cannot see demos, so we can take time on exploits. I had some exploits on Nginx, like there are integer overflows. This cannot be used with Nginx as a reverse proxy, but if you've got Nginx as a backend, you can try strange things with very long numbers. This was fixed last year. There's another issue which is fixed only in trunk currently, which is a 0.9 downgrade using HTTP 65536.9 or .8, where you can even use a post. And this is 0.9 query for Nginx. So you get no errors in the response. This is usually not transmitted by a reverse proxy to Nginx. Like you need to exploit these sort of things, you need to get Nginx as a backend, and you need a reverse proxy which transmits this bad syntax. And this usually doesn't happen, but in the past, Haproxy was transmitting this to Nginx. And Haproxy is one of the best HTTP tools against smuggling. Another one here, it's a CV against Varnish, where the CR end of line was valid, and you could also use double content length headers. There's another one, but I can't remember what I can't read it. Another one on Apache, like it's on the chunk size attribute. So when you do chunked transmission, you've got chunks with a size. There was a truncation, like only the 31 first character are read. So you can use 0 character and try to alter the size of the chunks. This is now fixed, of course. There are all the other exploits I showed previously in Go, in Apache, like the no cache poisoning in Node. And there's also other peoples which fix overflows, like we had one in Python URL lib recently. And on Node, there were others. So how do you protect against this? The first thing is to use the last RFC, which is 7230. And a lot of people are still using the very old RFC for HTTP 1.1, which is really very, very old. You should really try to reread the RFC, because on this new version, there are a lot of things against smuggling. Like they said, you should try to avoid chunked and content length. You should really avoid rewriting your own reverse proxy because it's a very hard stuff. But in case of, if one day you try to write a reverse proxy, the goal of a reverse proxy is to rewrite all headers in a very clean way. Do not take blindly the headers I sent and give it to a backend. You should try to read books on TCP/IP socket connection because it looks like something like an abstraction which is simple, but in fact it's really not simple. You should also think about browser, and browser do not make HTTP errors. A lot of HTTP servers are still allowing a lot of things like HTTP 0.9 because of monitoring tools which use 0.9, or because of bots, or because of bad implementation on the wide. But I think you should reject bad implementation and you should restrict what you allow in HTTP. You should be intolerant, and this is one of the problems. There is this sentence, which was in general, an implementation should be conservative in its sending behavior and liberal in its receiving behavior. But maybe it's wrong. Maybe the right thing is it's not being liberal, it's being robust. Like you should think that you may get some bad things and you should handle this thing. Maybe you need a special error message, maybe, but do not fix the things blindly. And there's a new RFC, which is called Draft Thompson Postel was wrong, which is talking about this thing. We should not be intolerant on the protocol implementation. I think also that you should be able to get more options on the HTTP server configuration. Like you should say, I do not want to support HTTP 0.9. Because even today, you may get an HTTP 2 server in Go, for example. You've got very nice HTTP 2 server, but there's still the HTTP 0.9 support inside. And you should also be able to get the keep alive thing without the pipelining. So there's no option to say there's no pipelining on this server. You could also try to get back to HTTP 1.0, but you'd get some problems of performance. You may also think, I was thinking this, that adding a reverse proxy will secure your installation, and maybe, in fact, it's the contrary. Every time you add another layer, maybe you add another issue. The reverse proxy trusts the backend response, and it's the way it works, and we never think it works this way. It means if you've got a reverse proxy and you've got a backend with a PHP application and you let everyone write PHP application, everyone can break your reverse proxy simply by sending several responses. So the reverse proxy will always trust the things from the backend. And we do not think this is the case. Think about things like Haproxy, because it's a very good tool to remove everything which is strange. Nginx as a reverse proxy is also quite nice. The next Apache mod proxy will have the strict protocol option, which is nice. Is HTTPS protection? No, it's just a layer. So it's not a full protection, because inside, after the SSL thing, you've got just HTTP 1.1. And maybe when you add an SSL terminator, you just added another HTTP server. But HTTPS is great, of course. Is HTTP 2 protection? Yes, of course, it's better against smuggling, but you can always ask HTTP 1.1 for an HTTP 2 server. It's just another transport layer. Just the last thing, I wrote a tool which is called HTTP Wookie. It's an open source tool. I will release it today or maybe tomorrow with tests. The goal of this thing is to test reverse proxy implementations and to fuzz HTTP. I need to remove some of the tests which are not fixed yet everywhere. But if you need to fuzz your own server, you could use this tool. If you got any question, I will be outside. And that's it. And thanks for everyone.